I'm messing around with my calculator. I finally remembered to bring.
You're kind of boring.
Awesome.
I have to find out how to use it now.
I need to find mine so I can charge it.
Oh, let's go to this here. So let's go. First things first is I have to redo this again just real quickly here. So schedule wise is this right here. Today we have any homework questions from 3.4, and 3.4 is the most that we're going to go in chapter 3. We have a test this Wednesday on chapter 3, and you guys were given a study guide a little while ago. Is that right? Okay. And then we are going to skip chapters 4, 5, and 6 because that's trigonometry. We're going to jam to chapter 7. And then we're going to jam through chapter 8, probably, maybe get to 9. We'll hopefully get to 9. So in that process. Okay.
Did you say we do 10 after 8?
And come on. Yep, sorry. 8, and then hope we get to 10. And even if we get past that, then we get to 9. Okay, with that said, boom, there's the schedule here. Second thing is the study, no, this is a formula sheet. So formula sheet, I put in definitions of the exponential function, definition of the log function, definition of the natural log function, and the change of base formula. The rest of it, you do have to sort of implant it in your head. Are we good?
So like all the rules and stuff?
None of the rules this
You said we
time.
got some of the rules.
Oh.
Oh boy.
Oh.
I've got rules to memorize.
Are you even listening?
That we have
Let's
to
see.
memorize?
The rules themselves are, so like the limit ln of 1 is 0. We good?
Can you go over those today?
Yeah, we should go over this.
Yeah.
Make sure we
Wait,
got
so
it.
there's gonna be no, is there still gonna be a formula sheet?
Just the change of base formula,
You just
natural log, definition of exponential.
Okay, yeah.
So that little piece right here. The rest have to memorize. So let's list them out, all the rules that we have so far. So we have. Okay, there's that. Remind me so I don't forget. Okay, next is the study guide itself. So I did not bring that up. Chapter 3 study guide, this guy here. Let me bring it up. Okay, so we do have, first things first, is we have a non-calculator section of the test. We also have a calculator section of the test. So half the test is a non-calculator test. And then the other half of the test is a calculator test. We good? So real quick here, how many will need a calculator on Wednesday for sure? 1, 2, 3. Okay, I have 3 calculators, so we're good. We're good. So hopefully that's the way it'll be as we come in. Dylan, question.
So you guys, there's 2 in the non-calculator section. There's 2 things that say find the exact value of the logarithm. What is the difference between those 2? Like for 7, 8, and 9.
Oh, so find the exact value means you end up with like x is equal to e to the 5th, and that will be the exact answer.
I think what you meant is why it's listed twice, because one says without using a calculator, but they're both in the non-calculator section.
Oh, gotcha. Okay. So 7, 8, and 9. Thank you so much for the clarification here. I don't know if as I was thinking about it, definitely don't want to use a calculator, and then I did not put that in here.
So are all 3 of those problems going to be the same thing then?
Yeah. All 3 are the similar. I'm thinking maybe this one had the ln function, and this one was just the plain log function. I think that's the distinction as I was building it. Probably. Okay. And then use the sum, difference, and or constant multiplier of logarithms to finish up that. And then I think I did it. You guys talk to me here. I think these are the exact, I did a better job this time, I think. I went through the homework and I copied the way the homework is stated for them, right? Is that right? So as you look in your textbook, just make sure. So question 1 and 2 on the test, if you look at chapter 3, 3.1, on your homework, on the homework itself on page, let's see which page number we're on. Yes, okay. So class real quick here on page 227. So I literally, for number 1 and 2, you should see these exact same directions on there. And it'll be a set of homework. It's actually 45, 47, 49, and 51. So what I'll do is usually I pick that problem, I'll pick a problem, and I'll change up the numbers just slightly in that problem. So a base of 3 goes to a base of 2. And then I'll change the other side around. But the way you solve the problem is still going to be the same way you solve the test problem. Okay, we good there? That's one extra thing I wanted to make sure I did on the test. Okay, so calculator section 11 to 17. Change your base formula. Solve a logarithmic equation to 3 decimal places. Oh, sorry, exponential equation. Then solve a logarithmic equation. And then there's some honor section as well here. So honor section, a little bit more tough. Evaluate this function. Solve a logarithmic equation algebraically. And then an application problem. Something you've never seen before, usually, but then it's like, oh, but I know what I've learned so far. I think I can figure this out, or thing like that. That's what usually that guy is all about. Okay, any questions on this little guy? Okay, Tristan.
Honor section, calculator.
With calculator, yeah. I'll do with calculator. Landon?
I was just wondering, when you say, so calculator and non-calculator section, is that like you're barred from using a calculator on the non-calculator section, or you have to use a calculator on the calculator section, or is it just like these problems require a calculator?
These problems require a calculator.
Okay.
You guys will have 2 different printout of the tests. So you guys will have a non-calculator printout of the test. Once you finish with that, I will hand you you give me the non-calculator portion, and I give you the calculator portion. Then you finish off the test that way.
Okay.
So it'll be that little piece.
So it's a
there.
2-part test.
2-part test.
Okay.
And then because the honors is extra credit for Canon students, honors requires a calculator anyways, so you'll be hooked onto that second part of the test. So it'll be 2-part test with the honor section stuck into the second part. Cool. Good. Thank you so much. I'd make sure that's what you guys expect when you guys come in on Wednesday. All right. All right. Any others? Going once, going twice. Okay, so let's do this here. First things first is any homework questions from 3.4. Raise your hand if you have any first. Okay. We'll handle those. Next, we'll jump to the properties of them, and then we'll jump to the review of anything that we can do.
Is 3.4 do that with it?
Yes. And then do we have do we have 3.3 due already or no? Did I put it on the list?
I don't think
Put
it's
it
on
down?
the-
Okay. I will make 3, even though I do want you guys to do the homework before you do the test, obviously.
Yeah.
Not to wait last minute, but as far as due date,
Tuesday night.
I can probably do it Tuesday night just to make sure you guys put it in already. Okay, 3.4. 3.4, go for it.
I have 91.
91, Anybody else? Charlie? 111 and
113.
and 13? Just make sure, is that right? Okay, perfecto.
113.
It's 113, there you go. That something was off. Usually don't go from 100 all the way back to 13. Okay. Boom, any others? Going once, going twice. Sold, okay, let's go in order. 91, 91 it is. Let's go with solving this guy. So I got ln of x plus ln of x minus 2. The question is, when is this equal a 1? All right, so first things first, whenever I solve these guys, I have to put it into one single ln function, just so it's all set. That little plus sign means I'm going to multiply these guys together. Oh, a little rule off to the side. It says ln of a times b is equal to ln of a plus ln b. If we kind of put a little rule to it, it's called the product rule. Okay, so ln of x times x is x squared, x times minus 2 is a negative 2x. Got that in there. All right, because it's ln, we are going to use one specific base to put in. E. All right, so E is the base. This ln stuff actually goes into the exponent just for a little bit. And then E, that little guy goes in the exponent there as well. What happens here though, E and ln, they cancel each other out. Oh, let's put this on the side. E to the ln of x is just x. Well, we'll develop a whole bunch of rules here by the time we finish. So that cancels off and that cancels off. So instead of being in the exponent, it just kind of drops back to a regular number. And I could write a 1 next to E, but I can just write E, and that's fine too. Okay, let's solve this guy here. Ooh, you know what I see? I see an x squared over here, and I see an x. I see a square term, and then I see a linear term, we call it. So in this case, I know I'm going to set up for factoring. I'm going to bring this over, and I'm ready for factor or quadratic formula. And with the E being on that side, I'm going to use quadratic formula. There's no way I can get that all set. So x is equal to quadratic formula says negative b plus or minus the square root of b squared minus 4 times a times c. All over 2 times a. I think we know the quadratic formula already now. So then we go for it. Let me go back up here. All right, keep on going. Let's see what I get here. I have myself, inside the square root. Inside the square root is negative 4 times negative b, so it's 4 plus 4e. 4 is a perfect square, so what happens here, it actually gets to be factored out. It leaves us with something that looks like that. And then the 4 can be taken out as a 2. And then the easy way to divide all this out is we just figure out what number goes into all 3 of those multipliers right there, 2, 2, and 2. And I'm left with 1 plus or minus the square root of 1 plus e. That was a not very nice one. Let me check back to the book here. You guys talk to me. Did Bob say that was the correct answer? Dylan, do you know?
I didn't know how to go from one part of the quadratic formula to that, so I looked on this later, but I didn't write down the answer because I didn't understand it. So I ended up asking, so I don't actually know.
Gotcha. Okay. All right. It is one of those calculator ones here. So
Shouldn't there be another 2, because you have 4 plus 4e, and then you take out a 2 for the 4, then you factor the 4 out of the 1 plus e. And then, should there be another 2 somewhere?
Should not be. Say that again. Say that again, Abe.
So you take the first 4 out of the quadratic formula, or out of the square root, it's 4 plus 4e.
From here to here.
Divided by 4, so it's 4 times 1 plus e.
Yeah, but then where does that 4 go?
It goes out to the 2. The 2 in front.
I know, but then where did the other 4 go?
Oh, sure. Yeah. So let's go for it here. So whenever you have factoring of numbers, right? Let's say it's 9 plus 9x, right? If you factor out the 9, you're just left with this right here, right? Because now you got multipliers. And if I were to make this into a square root, I'm saying to myself, hold on, it's the square root of 9 multiplying the square root of 1 plus x.
No, yes, that's where the first 2 comes, but then you have 4 plus 4e, where does the 4 go, the first 4?
Well, that's what he's saying. It's the same as 9 plus 9x, which is just 9 times 1 plus x. So it's the same as 4 times 1 plus.
I factored out the 4, or in this case, I factored out the 9. That makes sense there. Yeah, so 9 plus 9x. This guy becomes this guy's a factored form of 9. Did I answer your question, Nate?
Yeah.
Okay. All right, here's what we got to do. Guys, think about this here with me. Get out your calculators as well. Oh, I got to give you guys calculators here. I need to know whether 1 plus square root of 1 plus e and 1 minus the square root of 1 plus e work. So can you guys punch this into your calculators? See, the way it's probably gonna punch into the calculator would be 1. I just need to check. Hey, what are we checking for anyways? What are we checking for?
That ln of x plus ln of x minus 2 equals 1. Right?
No, we're not checking whether we have the correct answer.
It has
We are
to be,
checking to make sure.
Positive or we put 0 when it's called back in the
Yeah, whenever we take ln functions, right? Remember ln functions from our graph? It can't go beyond, it can't go, actually, it can't be 0 or lower. So here's what we gotta do. We gotta check this. Notice you have ln of x over here, guys. So this can't be equal to 0. This has to be positive, but notice what over here. Look at this, we have ln of x minus 2. What does that mean, anybody? What does that mean as far as our answer is concerned?
Yeah, but it's at 2 for it.
Yeah, so if you have a positive number, let's say you had like 1.5, right? And you subtracted 2 from it. And then you took ln of it. Is that a problem? Punch this in real quick here. Do this here. 1.5 into your calculator before we do this. 1.5 minus 2. Right? And then take ln of that number.
Non-real answer.
Not a real answer. Yep, it's in this little domain right here, right? So if I had a problem like this, let's say a log of x plus 4 plus log of x minus 8 is equal to 32, blah, blah, blah. My answer has to be bigger than what number? Isabel says 8. Talk to me if you guys agree or disagree. Agreed, you're right, because by the time you take the log function of it, the log function has to be positive. So it has to be log of a positive value. So back to our problem. So this guy right here says, let's see if this we can put into math language here. Talk to me if you guys agree. This guy says that x has to be greater than 0. True? This one says that x has to be greater than or equal greater than 2. Are we good there? Okay, so now let's do this here. Now let's jump to this. On your calculator, punch in 1 plus square root 1 plus e to the 1. The way it's going to come up is when you hit the e button, it's going to go like this. You close off the exponent for this one, then you close off the square root. And what do you get? Awesome. 2.9. Anybody second that?
Yep.
Okay, good. Okay, so now I know that the positive value works. So I know this is one answer. Okay, now do the same thing. Everything is the same except for now we've got a minus sign right over here. So let's put a 1 minus the square root of all that. Now what is that number? Do it. Anything less than 2 is not going to work.
-9. Wait, no, -0.9.
Oh, okay, negative 0.9?
0.928.
Oh, forget it. Okay, that one does not work. Okay, so then for our answer is just this little piece right here. And then on the book, it actually says, also give it to me in 3 decimal places. So this would be 2.9. Sorry, can you do the other one again? 2.28. Perfect, okay. So there it is, exact answer and approximate answer. Okay, this 91 seem easier now. Dylan, are we good with that one now?
Yeah.
Okay, that was a tough one. In fact, I think it's actually tougher than 95. As tough as 99, but definitely, probably even tougher than 99. That was a oop-de-loopy one. Okay, comfy though. With 91, everybody comfortable with 91 now? Okay, 111, let's go for that one. This one also needs your calculators here. So let's go with the yield, V, or volume, millions of cubic feet per acre for a forest at age T years is given by this. Whoa, okay, hold on. So V is equal to 6.7 e to the negative 48.1 divide by t. Whoa, okay. Use a graphing utility to graph this function, determine the horizontal asymptote of this function, interpret the meaning of what the problem is, find the time necessary to obtain 1.3 million cubic feet of
Oh,
force.
we did this one.
Yeah, we just graphed it on a calculator last time, right? I just did the graph for you,
I
then.
went to the graphing, it was already in there.
How cool. Awesome setup over here. Okay. Let's see, what do I have? Okay, shucks, don't have it. Okay, 6.7. So, those are dealing with me here. So real quick here, go to y equals right here. So we're gonna punch in 6.7, and then we're gonna punch in the E button, which is right next to ln. And it's gonna be a negative. This guy right here is your negative. That's your minus. There's two different things. So negative 48.1 divided by, now your calculator determines always in terms of y and x. So once you press this little guy right here, it's going to be your variable button right here. It's going to be x. Close off the exponent for e, click enter. Okay. Before we even graph it, right, we should know the shape that we're looking for, right? And so graphing that guy. Okay.
We have to zoom out to like 60.
So zoom, and number 3 is zoom out right here. Dunk, 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 dunk. Click enter, zoom. Oh, it's all the way over here. All right, is that what you guys have? Zoom out again, so number 3. Wow, okay. Taking the asymptote. Let me just check. Why would you be in the negative x's? That does not make sense, ability. Four. This is 3.4. 100. One second, class.
When you
Pick
have an
up on this here,
exponent
yeah.
like that, how do we know if it's supposed to be an exponent on just the e or the whole thing? If there's no parentheses, is that just the
It's just
exponent on
the
the
thing before, it was for parentheses around the 6.7e, and then you had the
e? Yeah, then
parentheses,
it'd be different.
then you would have, then it'd be for the whole thing.
So it's either above or below here. As you zoom out, so zoom again and zoom out number 3.
Nothing happens.
Still nothing happens. No way. Zoom out again, number 3.
Zooming out many times.
You won't even be able to see the hash marks anymore when you zoom out. It's just really big.
I have some, I have like.
I don't.
How big is your?
And I get this little guy right here. I get this little corner.
There you go.
I guess
Zoom it out.
You guys talk to me here. The problem is what's the problem here? What's the problem in quadrant 2?
That's negative.
It's negative. It's on the left side of the y-axis. And if we're talking about time, the time it takes in years, that does not make sense. So then what we do, and I notice extra little something here. Do you guys notice on your calculator? You have these little ridges right here. And all of a sudden after this, it stops, it becomes solid right here, right? Boom, boom, boom. So let's do this here. Let's first of all, forget this side because the negative side, it doesn't make sense to have negative time. Let's go up to the positive side and let's bring this. Also, you can't have a force grow negative value, right? So there's no need for us to actually have quadrant 4 either. So let's just focus on quadrant 1. We're good? Okay, so let's do that here. Let's see. First of all, let's see how far we're out along the x-axis. So window. Everybody click on window, yeah? X minimum is going to be 0 for me. X max, it means I was at 40 already. So I'm going to go every 10 units. That's fine. So this little X scale just means where your tick marks are at. A Y minimum, I don't need to see negative values because the force is not in negative values. My Y, my X max, yes, but I want to go just a little high because I'm thinking maybe let's start off at 10. I'm going to start off at 10 just to sort of see where we're at. So window setting is 0, 40. X scale 10, Y value 0, 10, then it's 1, 1.
Did you start recording again?
I did start. Thank you so much. Okay, so let's see the graph. Let's see if everything happens anywhere. Oh yeah, I see it right there. Finally. Okay, and then tell me if you don't see it on your calculator, I'll come by.
What were the settings again?
Let me give you settings again for the window. Right there, 0, 40.
Scale. Just it'll keep the X.
I was like, I only need like the.
Oh, now I see it.
It's much cheaper and this doesn't do anything I need. Oh, yeah.
That's just too close for me.
Okay, anybody else having trouble?
History is sad.
Are we good there? Yeah, good? We're good? Are we good? Okay. And Landon, check on you.
I think I'm here.
Okay, and Dave Owen, good?
Yep.
Okay. All right, we got our graph, da, da, da. So now we can finally look at stuff here. So use the graph to graph this function. We graphed it, da, da, da. Determine a horizontal asymptote for this function. What?
Quant? No. No, there is one. There is one.
Yeah.
0.
Horizontal asymptote for E function is going to be 0, right? Y equals 0, right? Because you can't get, in fact, horizontal asymptote for this function, the way it works is because we actually are talking about real objects this time. And you have a growth on you. And so real quick here, if you have something growing, Abe, look at this here, because it's actually a real thing, right? It's not like we start off with 0, because if you start with 0, you get nothing in the first place, right? There's no such thing. And so we should have at least started off with 6.7. Then from here, that's when it took off. That's when you have sort of something looks like that.
But horizontal asymptote still do.
So the horizontal, no, so horizontal would then have to be 6.7, because that's the time it never crosses, even though it more like goes like this. Here's my 6.7. It kind of does more like this. Gently rolls around and then stops right there. So determine the horizontal asymptote of the function, interpret its meaning in the context of the problem. So we say initially, there was 6.7 million cubic feet per acre of forest. We good? So for A, the graph is good. For B, determine the horizontal asymptote. And let's see, how should we do this? Oh yeah, it's V. So here's my horizontal asymptote right there. Or you could say HA, that's fine. We've been doing HA on the previous thing. HA is 6.7. Oh, no, hold on. How did we do them before? Here it is. We put colons, huh? We put colons and then it says y equals because it's a graph, right? In this case, it'll be v is equal to 6.7 because that's the v right here. Interpret the meaning of it. So initially, there are 6.7 million cubic feet per acre. Sorry, chicken scratch there. Find the time necessary to obtain a yield of 1.3 million cubic feet. Oh man, that's no fun. Okay. So it's, let's see, find the time. So that means actually we're trying to find the t value when we're actually given the yield value. Oh, bummer. That turns out to be a algebra problem. Here it is. It's this. Negative 48.1 divided by t equal to, let's see, and then we got to do 1.3 million. This is already million, right? 1 million. In years. So of course, t given t years is given by that equation. Is it going to be that much? Let me just check something out real quickly on the calculator. I'm going to trace this guy starting here. X value. It should be there, yeah. Huh. I guess so, yeah. Let's go with 1.3 right here. That's what we're gonna try to find.
I'm not misunderstood the problem just because I didn't actually read it
Uh-huh.
right now, but how do you, is there's initially 6.7 million cubic feet, and then how long it takes to get 1.3 million? 1.3 million is less than 6.7.
Let me
They're
check.
trying to figure out how long until they have that much money left, right? Is that like the idea?
Yeah, let me, can you guys do this here? Can you punch in, for this guy, can you punch in point like 001? I think the graph is not, what do you guys get for that?
Tracking?
Sorry, computation wise.
I got 0.
Yeah, I also got 0.
Okay, can you now punch in just 0.01.
Oh, you want us to like calculate that?
I got 0 again.
0, okay, and now put in, we're gonna get there here, so 0.1. So that means it's a 1/10 of the year, right, just barely.
0. I got 0.
Okay, put in a 1 now.
-8.63992,999,
Okay, so maybe the graph is off. Let's take a look at the graph. So let me do this real quick here. Let me give a little bit of, for the Y minimum, I'm gonna go down to like -2. Just so I can see my base on the bottom there. And then this guy, I'm gonna make it a little further out. How about 100? I'm gonna see what happens there. So this is just me. I'm gonna go from 0 to 100 along the X's. -2 to 10 along that. Let me see. Let me mess with the graph just for a little bit longer here. This is what, whoa, look at that. Totally different.
What?
Wait, what'd you do?
Look at that. Let's go back to window. And I went out all the way to 1500.
Oh my. For the max?
Uh-huh.
Oh.
Wait, what did you have to do?
Uh-huh, so 0 to 1500 for the X. Scales by, we can just go by hundreds, I guess.
Did you do 1500 for the Y too?
No. Y is still the same because at least I saw my graph in there already. So my Y is still -2 to 10.
Just Y just goes to 10 then? Why is it at -2?
Just so I can have a X-axis showing.
Oh, okay.
Because if you do 0, some calculators will chop off the X-axis. You feel like you're in space as opposed to being somewhere. Yep, so I got this little graph now like this.
Whoa.
And now I'm gonna click trace on this one now. Let's see where I'm at. Oh, look at this.
If you zoom in more, will it get more accurate?
On the trace, no. On the trace function, it's kind of preset the way it's gonna go.
Oh wait, there's a second part of the graph. I kept going to the left and I found more.
Yeah, but it doesn't work when we're doing time.
Yeah, time, yeah.
How far to the left?
So I'm gonna go back.
Can I go?
That's my question.
I'm gonna go back to like 200. I wanna see what happens with.
And then it starts on the next one.
Okay, I can see the curvature. So it started out very, very low at first, and then it picked up speed for a little while, and then it curves out again. So I didn't see the rest of the graph here. The graph sort goes like this, really.
Oh, let's see how long it takes for it to get to 7.
So it goes like this, and then it goes like that.
X equals 3,000 and Y still equals 6.
I was gonna say, how you passed 7 on the X a while ago.
No, the Y still haven't passed 7. It's at 6.69, 6.61. Oh my word, this is gonna take us.
So Isabel, I was wrong. What happens here is that you do have a horizontal asymptote, but it's this guy here. Oh, and does it ever get beyond 6 point?
At 6.63, and it's slowly just slowing
Now,
down.
that makes sense, because notice what happens here, guys. As this T becomes bigger and bigger and bigger, this whole thing becomes smaller and smaller and smaller, right? Almost to the point of going in to become just 1.
So then, and then when it's a negative, it makes the number bigger. That you can get out. The negative is later.
That negative actually more, it gives you the curvature. The negative is actually giving you the curvature of it. But notice real quick here, guys, if I have a number like this, if I have a number, 50 divided by 1,000,000, small number or big number? Actually, you do negative, because it's 48 is probably close to small number. Yeah, and if I keep on adding extra zeros here, where does this number keep on going to?
Small.
Yeah, it keeps on shrinking all the way down to 0 practically, right? And so if technically we have this guy becoming a 0, what is e to the 0? 1.
Oh.
And so then it really becomes, so Owen is never going to get to 7.
Oh, and
At x equals 1 million, it's still 6.6.
Uh-huh.
I still have no.
6.699999, but it won't get to 6.7 ever, because you never get to 1.
Okay, watch.
Okay, before we go here, we didn't get to the last one. Sorry, Charlie, we didn't get to 113. Let's go to this in the last minute, real quick here. Let's go through the properties that we have really quick.
It's stuck on 6.7.
Really?
Yeah, it like flatlines, but it stays in 6.7.
Really?
So-
It's not actually 6.7, it's just so close there.
It's like 6.6.
It's almost like.
99999. Yeah.
You just put a line
It'll
over it.
infinitely go up, but just slowly, so that it never gets to 7. And then once it gets to that, it's like 6.
Oh, wait, why does it go out? It's 6.7.
And then all of a sudden it goes to 8. It just skips 7.
Let's see, I think these are the properties here that we have so far. I'm gonna just list them here.
But I have the jumper.
Wait, can you explain one more time? So that we have 6.7e in the y value, the graph will never get above
We already done
6.7.
that.
Why is that again?
Sure.
New York City.
For Owen, here we go.
Because I was trying to figure it out.
Uh-huh. So as this number here, it's kind of close to 50.
Oh, when it hits 0, oh, I see. But it'll never hit.
It won't hit 0, close to 0.
Yeah. You can never have a division problem.
So class, I'm gonna write down the log functions real quick, the log properties. So ln is on one side, log is on the other. So if I have log base b to base to the x is equal to x, and then b to the ln of the same b to the x is equal to.
Should we have these memorized or will you give these to us?
You can memorize.
These are the ones you have to memorize. So I'm gonna have you guys go through the homework and then the addition rule, product rule, and quotient rule, those guys.
Can you put these slides on, are you gonna put the slideshow somewhere? Or not?
Video, yeah, video. And let me finish up the rest of the table as well, then I'll send it to you guys here. So log, in fact, I may just want to send the whole log functions here. Let's do this here. I'll send you guys, I do want you guys to memorize for the test, but I'll send this to you guys. Today, we're good? So I'm gonna just do one more, just those that are copying me can finish it off, log base A, but the rest of you guys are excused. There's your,
Thank you.
sure,
Thanks, Mr. Anja.
absolutely, have a good rest of the
This is why we
day.
have Owen. I don't want to lose my seat in his chair. I got prime seating today.